internet, definitely we'll discuss about the history, how internet has been evolved, how it has been developed, and how it become an inevitable part of our life now, and what will be the future direction of internet. Okay? And obviously, like, if you have any question, just raise your hand and ask your question, and that's the purpose, to make it interactive. Alright? So as you already know by this time, I'm coming from APNIC. How many of you heard about APNIC from here? Or probably I'll ask the question other way around. How many of you haven't heard about APNIC? Okay. Yeah, APNIC is the registry of internet resources in Asia Pacific. So, what is a registry of internet? When internet has started, long before, right? So, for example, early 80s or late 70s that time, right? So, internet was an experiment of the US defense, and then afterward, the purpose of that experiment is to innovate a technology that US defense can use to do the secret communication into US defense different sites. Right? You all know the history of internet. It was a project of ARPA. And then, when internet became sort of this technology, when the people who were involved in that innovation, when they realized this technology is very, very effective and it could be very, very useful for the public, right? And that time, I'm talking about 30 years before, at that time, those visionary people who can see the vision, they actually open up this internet technology for the public use. Even though the initial objective was for the defense, they will use, right? But then afterward, they have opened it up for the public use. And this is how internet become available for the public. I'm talking about 30 years before. So when the normal people like us, they started using that internet technology, then this technology actually has changed the way we live our life, the way we think. Any idea how it has been changed our life? Well, probably I can see the friends who are here has born after internet has been developed, right? So you have already sort of grew up with an internet environment, right? But before, 30, 35 years before, when there was no internet, the perception of people were different, right? And at that time, the research, experiment, those sort of activities was very specialized. Only the very clever people, very intelligent people, they should do those sort of activities. But normal people just live their life. Make sense? When internet has been developed, then this technology become sort of a carrier to exchange information. I can remember, like when I was in the school, in college, to get an admission in a US university, I had to write a letter, post it to the university, right? Then they post their application, brochures, everything by post. We had to wait like 1 month, and then that came. I applied, again it went, altogether like 6, 7, one year job altogether. Anyone here went through that experience? Yeah, that time it was like that. Information was not available, widely available. It was available, but you have to put effort. Make sense? That time, the way we do banking, the way we get services by the government, all were very manual. If I need to have a passport, right, I have to go to the passport office. And everything was manual. It takes time. Even how to apply passport, what I need to collect, I have to go there in the office and get those information. Did you see the perspective that time? How people used to live their lives? When internet became available for the public, then the industry realized, oh, this technology can change the whole life. Right? Well, initially when internet was developed, we didn't have email service like this that time, very early days of internet. Then we didn't have that www service that we have now, like browsing, right? Then slowly those applications has been developed in internet, like email service, web service, right? Now we have Skype chat and everything. It was not there at that time. So, and this is how internet actually start changing the way we live our lives, right? Okay. When internet technology has been developed at that time, if you see the history, in fact at that time, two technologies actually developed parallel. One is the internet, not an organization represented by any government. This is a forum that is not represented by any individual business organization, right? It's a forum of all good people. They would like to make things happen, make the technology benefited for the people, right? So this is how IETF, when they formed the IETF, the group of people like the scientists as I'm saying, so their initial objective was whoever developed any technology to complement internet, right? There are lots of technologies that has been innovated, that has been developed during the whole lifetime of internet so far. Some of the technology become very widespread, very sort of effective. Some of the technology probably didn't cope up with the growth, right? So when any vendors, they develop any technology to complement the internet, they went to IETF at that time and asked IETF, okay, I am XYZ vendors. I developed this technology. Can we make it a standard? Why do we need to make it a standard? Because if the technology becomes a standard, then other vendors, everyone can develop product following that standard, right? Then what is the benefit? Benefit is if you have a Microsoft Windows operating system, you can send email to a Linux machine. So it's called multi-vendor platform. Make sense? So this was the initial sort of motivation in IETF to make the internet technology become very effective, very useful for the common people. Right? Parallelly, if you see the other technology has been developed, it was not developed as a very widespread. Because up to some extent, those technologies are vendor locked. Make sense? And we saw that, like there are lots of technology has been evolved last 100 years, right? And because of the vendor dependencies, like in IBM, there are lots of technology that IBM has got, only IBM specific, right? And that technology was very useful at one point of time, but in times, those have been phased out from the industry. It's just people demand, people's choice. That's how internet has been evolved. Right? Okay. So, as a student, when you will be studying computer networking, computer science, computer engineering, right? How you can flourish your career, how you can be part of the internet development, internet growth. What I can see, go and participate in ITF activities, right? What other technology has been developed? What are the standard, future technology standards are being discussed in ITF? ITF has a website. I don't need to give you the website because Google is there for that. Just Google ITF, then you'll have ITF website. Go and see there are lots of working groups working in ITF. Right? If you are interested on computer networking, if you are interested on computer security, if you are interested on MPLS, right? Go and join on that working group. You don't need to go there physically. You can read from here. Just subscribe to their mailing list. They maintain a mailing list, right? Mailing list is an email group where you have to subscribe your email. Then, the next moment you will see email coming in. Even though the email was not sent to you, but sent to the group. And it will come to you. You read the thread, you read the email, then you will know what they are discussing. And I am sure, first 6 months, 1 year, you will not understand anything. Right? So complicated. But don't give up. At one point of time, you will build a skill. You will be part of the internet development. Right? So, yes, so this is how internet has been developed in an open environment. No one owns internet. No one can claim, IBM cannot claim internet, I have developed. Cisco cannot claim internet, I have developed. They contributed. They are part of it. They all build it together. Right? So, if you see internet as an open technology, it is changing our lifestyle, the way we live our life. As you saw, our previous generation, research, analysis was only being done by a special, skilled, clever group of people. But now, as I said, we all do it. How we do it? Research. How we do research? If I need to buy anything today, if I need to buy any mobile phone, if I need to buy any laptop, what do we do nowadays? At least we ask Google. Let's see what are the configurables. Right? Those are research, part of the research. Right? And if we use the research skill in our daily life, definitely our lifestyle will be improved. We will have a better life. Right? We have a choice. Now we have a choice. But before, I don't know, probably didn't have a choice at one point of time. Make sense? So, to understand internet, right, the technology, to understand internet, what it is and how it operates, what do you know about internet so far? Well, internet means like I have a laptop, or I have a desktop, or I have a portable device, I connect to somewhere, and then everything comes to me automatically. Right? Probably, for certain, like group of internet users, this is what the perception. Well, if you want to be a professional to run internet, if you want to be part of someone who is running internet, then you need to understand the technology behind it. Right? So in internet, if you see the devices connected to the internet, we actually group them into two categories. Normally, we classify them into two categories. One type of devices that connects to internet, we call it end system devices. What is that? End system devices means the devices connected to the edge of the internet, like your machine. right? So end system devices in internet is an equipment that will be used to exchange data across from one side to the other side, right? So end system devices. A laptop can be an example of end system device. A server, also an example of an end system device. A server, don't be surprised. Yes, server is also an end system device, right? So this is what we call client-server architecture of internet. So current internet is on client-server architecture. It means all the end system devices connected around the internet, some of the devices are acting as a server who serve data, right? And most of the devices are client, like your laptop. That's what we call client-server architecture of internet, right? So if I browse something from a laptop, what I'm doing? In internet, I am acting as a client and browsing content from home, Google. So the content is coming from Google server. Did you see the client-server architecture? Right? To run this client-server architecture, both devices, server and client, need a software. If you are using or if you are browsing internet, then you are using a web browser as a client, right? And on the other side, Google is using a web server software, for example, Apache, right? Or there are so many other web server software. So this is what is called client-server architecture of internet. Same thing goes for email. Same thing goes for your Skype, voice chat, everything. It's a client-server architecture. So in internet, the end system devices connected around, some of the end systems are acting as a servers and most of the end system actually acting as a client. Make sense? This is what the current architecture of internet. And how those end system devices, they carry the data across through some other devices in the middle. Those we call intermediate system devices. Make sense? So in internet there are two types of devices, end system device and intermediate system devices. End system devices are which type of device? My laptop, servers, all are end system devices. But in the middle, intermediate system devices, who are they? Did you see those devices? Some of you already saw that, probably. Like routers, switches, those are all intermediate system devices staying in the middle and help those end system devices to carry the data across. Right? Okay. So as a professional, when you need to join in any company, you have to choose which area you want to work with in internet. You want to work on the end system devices or you want to work on intermediate system devices. Right? So this is how we have got different professionals. If you see system admin, network administrator, system admin, network administrator, those are the role probably, or programmer, those are the role probably you people will be joining when you finish your study. Right? So those all, system administrator, network administrator, programmers, those all relates to the end system, edge of the network. You have to learn software, how to work with it, like server software, client software, how to work with it, how to make it work. Right? There is another group who will be working on the intermediate system devices, like routers and switches. the role can be network engineers. Right? So you need to know how to make the router works. Clear? And also from the end system to the intermediate system, from end system to end system, through the intermediate system, when the data are going, the data definitely need to have a protocol to communicate. That's what we call TCP/IP protocol now. So TCP/IP also has got a big history, long history, TCP/IP protocol. Because this is the protocol actually built the foundation of the internet, right? But that journey was not that easy at the early stage. When TCP/IP was developed as a part of US defense project, who has invented TCP/IP? A group of people. There are lots of people who was contributing to the development of TCP/IP protocol. It's a software, right? The key people who were involved in the development of TCP/IP protocol is Dr. Bob Kahn and Dr. Vint Cerf. So they are considered as the father of internet now. Have you heard about Vint Cerf? Dr. Vint Cerf, a US scientist. Dr. Bob Kahn, a US scientist. They have invented, or I would say, they have led the invention of the TCP/IP protocol. And at the same time, there are so many other protocols are there. Right? Like Apple has invented Apple Talk that time. Nobel has invented Nobel Network. Those are different companies. Right? But if you see, out of all those protocols, TCP/IP becomes the unique protocol nowadays. It's just sort of universally used. Right? So this is the evolution of the whole internet protocols. So you need to learn this protocol as well. Who has got a skill of visualizing how data are going across? They're the better engineers. Right? So for example, when data move across from the source to the destination, data actually goes as packets. Right? You all know that, right? Data goes across as a packet. As a skilled engineer, if you want to be a very efficient engineer, what skill you have to develop? Something similar to visualizing how packets are going. So for example, if you are browsing from this machine to the other machine, and in your mind, if you can visualize how packets are moving, because you can't see that. It's an abstract thing, right? You can't see that. But still, if you can visualize that, then you are a good engineer, right? And you know the protocol better. But if you don't know how it is going, then how you work? How you make it work? Make sense? So, yeah, so there are a number of roles that probably will be playing in the internet development as a professional. So, if you see on the slide what we have, we showed you some diagrams, right? What are those? I mean, definitely you can read, right? The purpose of showing this slide is, this is how we do the design. If you're going to read any design doc, right? Any planning doc, they don't probably write everything on a plain English. They'll just draw diagrams. And you need to be able to read it. So this is how we represent the routers in the design. This is how we represent a switch in the design. So you need to learn these languages as well. How a design can be written. How a design can be read. Right? That's a skill. Very, very sophisticated skill. So I have already discussed about what is internet host, right? So internet, as I say, current internet is a client-server architecture. But you see, this decision was not very easy to choose what will be the architecture of the internet? It completely depends on the evolution of the industry. Initially when internet was developed, 30 years, 35 years before, internet was peer-to-peer. The whole internet architecture was peer-to-peer. What does it mean? It means there is no server, there is no client. Everyone is a host. They exchange data. Make sense? It was like peer-to-peer. Everyone is host and they exchange data. Then slowly, when email service has been innovated, web service has been innovated, then slowly, internet has evolved from its legacy peer-to-peer architecture to client-server architecture. And we reached up to a mark, or we reached up to certain application of internet, right? So now you see, without email we can't breathe. Without web we can't breathe. Right? Without Skype we can't sleep. Facebook, oh my God, I can't live. Right? So this is what the current situation. But in future, in which direction internet is going? Internet is moving. In which direction internet is going? Like from now, next 30 years, next 40 years. Probably it's too difficult to predict in that way. But it depends, right? How internet is moving to us. The scientist people in ITF, what they're thinking, okay, now internet become an utility for us. It will be like water in my home. Before internet industry was using the telecom industry as an exchange, as a transport to send data across. But nowadays, if you see LTE and future NGN technology coming up, all are IP based, all are packet switching based. Now the shift has been other way around. Now voice become IP voice, called VoIP. Make sense? So industry has been changed. Using packet switch. Okay. When you need to deal with internet, in internet or in a communication network, there are two types of backbone that we normally see: switched backbone and routed backbone. Right? What is switched backbone? Switched backbone is when data are going from one side to the other side, right? It's almost from the source to the destination. They are using same type of protocol all the way through, from application all the way to physical level. Like in internet, say for example, I have a LAN in this building, right? So one machine of this building connected to the LAN, other machine of the building connected to the LAN. So if you see the protocol, type of protocol they are using, almost similar protocol. So data are going across. In a switch backbone, the limitation is the switch backbone cannot extend up to a wider geographical areas. What that means, like initially it was probably 100 meters, now it extended to up to certain, like 2-3 kilometers using fiber and signal generation techniques. And now around 5 kilometers, 10 kilometers we can rely on switch backbone nowadays, right? But if we need to extend it further from Cambodia to Bangkok or Phnom Penh to Bangkok, up to that extent, then probably our switch backbone cannot scale. Right? Why is that? Why is that? Because in switch backbone, the data itself need to work. Right? So for example, if I need to go to, it's like Riverside, as a human, probably from here I start walking, at one point I can go there. I'll be tired, but I can still go there. So data itself can walk. Right? But if you need to go to Bangkok from here, can you walk? Theoretically I can, but practically I cannot. Right? You'll be tired. So, what we should do then? In this bigger environment, we need to use a carrier to take us there. Right? What type of carrier? So for example, I have to jump into a bus or into a plane. Then the plane can take me. I'll just sit idle and eat, drink. Right? Much easier. So the perception is, in a switch backbone, data itself work. But in a routed backbone, probably data don't need to work. Data will just jump onto a bus and that bus will take us. Like microwave. What do we do? If we need to send data from one city to the other city, we have a carrier, microwave, like we tune the microwave modems on certain frequency, like 500 megahertz, 10 or 1 gigahertz, 20 gigahertz frequency. So that frequency is a bus. And data are modulated on top of it. That's what we call modulation. Right? And there are different modulation techniques for that. We need to learn. I mean, I'm sure you have already learned those things like QPSK modulation, PSK modulation, right? Loss of modulation. So, using that technology, data will jump into the carrier and then will work. Like, if I need to listen to FM radio, you have FM radio in Canada, Cambodia? I think so, you have. So, in FM, what you do? You just tune your radio on that frequency, 100 megahertz. FM, 100 megahertz frequency. You just tune your radio, right? When you tune it, then what do you listen? You listen, all the music is coming in. How come? Because from the transmission center, they are modulating the data into the 100 megahertz frequency and it's coming to you. From long, very far part of the country or the city. So in routed backbone, we normally use the transmission device, right? And we route data from one part to the other part using the modulated carrier. Make sense? If you see the infrastructure, in routed infrastructure definitely. In the routed infrastructure, which is the underlying infrastructure of the internet now, routing infrastructure, it's completely routed, right? There are a number of terminology that we use. Right? What are those terminology? Sometimes we call POP, VPOP, virtual POP, hub, super POP. What are those? We connect our home to the nearest exchange, right? So in legacy telco, every connecting point are considered as exchange, right? But in internet environment, the connecting point we don't call exchange. We call it POP, points of presence. Virtual POP. What is virtual POP? Nowadays, everything is becoming virtual, right? Nowadays, everything is becoming virtual. So we never know like from where data is coming. So virtual POP is, people live in this suburb, 200 people live on the other suburb, 100 people live on the other suburb, right? And we need to have a POP on different suburbs, for example. And all the POP need to connect to a central location, right? From there, you might need to go and connect to the different city, right? Did you see the hierarchy, how we build it? We need to build it into certain hierarchical architecture. We can't just build it as a flat. Flat network cannot scale, right? So if you see the hierarchy, then the devices that we use, the intermediate system devices that we use in different part of the network, we name them using different terminology. Some of the routers, if we put on the core of my network, we call it core routers. Some of the routers, if we put on the distribution part of my network, we call it distribution routers. Right? Let's define those parts, like core, distribution and access. Like normally when we think about networking like 10, 15, 30 years before, we didn't have to think about the scale because that time the requirement was only to connect, right? So what we did, from this side of my network, I start connecting and then I connect like 100 machines on a single cable. Then what we saw, when you connect 100 machines on a single cable, and if you see the way internet architecture has been evolved, it becomes client server, then out of 100 machines, 1 or 2 machines is actually serving most of the requests. Right? So if you see the data flow, all the data flows are concentrated to certain machines who are servers. Right? So from individual machines, client machine, probably there is no problem. But the server machines, he is suffering from bandwidth. Because everyone is coming here. Here everyone. Like I am here. If all of you need to come to me, from your side, probably if you have a small way to come, that's fine. But in my side, I have to have a big way. Otherwise, if everyone comes here, I cannot fit them in my areas, right? So that's how this architecture actually came into place. So we have to create a hierarchical architecture. Some of the devices who are client probably will be staying at the edge. What's the time now? The break time? Okay. Alright, we need to go for a tea break now. Then after the break, we ask questions. Alright, we'll continue after the break.
Okay, so before we have break, so we have Q&A sessions for participants. So let me start from the first question. So, what is MACONNET identity caller? If you guys know, please raise your hands. What is MACONNET identity caller? Please. Orange. Lady guy. That's right. The MACONNET identity caller is orange and gray. Thank you very much. MACONNET slogan. Gentleman here. That's right. So MACONNET's slogan is connecting you all. Thank you. Okay, now we find the second winner, and we go through the third winners for our Q&A sessions. So question number 3 is, what is MACONNET statement message? MACONNET statement message? Okay, let's see from the participants. Gentlemen over there. MACONNET statement message. You can look at on the phone. Okay, gentlemen in the front, please.
Beyond your ISP, your preferred ICT solution provider.
That's right. So, MACONNET statement message is beyond ISPs and your preferred ICT solutions. I will go through the fourth questions. Is what are the main key products of Mekongnet? Gentlemen.
The main key product of Mekongnet, I think there are 7. The first, fiber to the phone connection. IP transit. Third, IP LT. Fourth, DTLT. Five, co-location. And 6, maybe the wholesale bandwidth. And the 7,
Yes.
7.
Sorry, this is not a correct answer. So let me hear from the participant, please.
Internet A.
Yeah.
Internet, IPLC, DPLC, VPN. Close device, the data VPS device, image device, PSR, and ICT solution.
Thank you very much. This is a great answer. So, the key products of Mekongnet is Internet, ICT solutions, data centers, wholesale, managed services, and LPLC, DPLC, VPN, and cloud service. So, for last but not least, the last question for participants is very easy. So, what is Mekongnet Online? Lots of participants. So we have the 2 ready. So let you first. You listen first. So please.
The Mekong hotline is 023 22 66 222.
This one. Thank you very much. So 023 22 22. So let's have in Mekongnet. Director, please come to give VIP gifts to our winners. Thank you very much. So let's take a break for 20 minutes and we will be back at 10:20. Thank you.
นี่มันตึก
trời yeah bàn này trời chỉ là cái lùi
đó
yeah lùi vô kia mà đi mong break chứ cũng được slide ní đặt streaming mong bảy cái lại vậy anh vừa ở việt đã tham break ham mà đã có điện thoại để chơi đã break
thơm ngon ngọt á
rồi nơi coffee đó đã break á ngon pin đâu chơi được
nói xong vui hơn hơn không có nhau lại vậy
đã stream
đi lên nói xong vui hơn không có nhau của mình
không ấy miền này ao ấy cái dân lan nó sờn này nhưng không vô mày cái tên mà cầm đấy đi chứ là phân có được cả
vô không thôi là cả
tiếng ha đây khi em làm
chim tố cái ai kịch ní chim la này
dù ai
là thầm lại bớt à không may
thọt rong càng em muối ớt đi thọt rồi nè
trong hộp con này mà hộp con
cái dương kia nói xí vậy
xí đó nó xí đấy cái đạo xí rồi đấy đó
dương nói xí mà
thì đấy nó mấy